Hello and welcome. These are the notes for 5.2, completing the square. We're going to talk about perfect squares today, and if that's something that you're maybe haven't brushed up on in a while, then you may want to watch a video on factoring perfect squares and kind of some shortcuts there. That's really going to be helpful today as we move forward. So far we have been looking at solving quadratics with a squared x and a constant. Something similar to x squared plus 16 is equal to 25. But today, not all quadratic functions look like that. Not all of them are so convenient. So today we're going to be looking at more popular quadratic equations that have a linear term. So you'll see the example that I have here is x squared plus 8x plus 16 equals 25. So to solve this, we need more methods. We need more tools in our toolkit. So we're going to be talking about what it means to complete the square. I've got a example worked out here, and we're just going to use this as an introduction. So it's not expected that you look at this and I explain it once and you totally get it. I'm just going to give a little bit of an overview before we get into what we're doing here. So for this method, let's say I have an original equation like x squared plus 8x plus 16 equals 25. If I do a quick factorization, all right, and we recognize that x squared plus 8x plus 16 is a perfect square, we can use what we know about factoring perfect square trinomials to rewrite this as x plus 4 quantity squared equals 25. Then to work to solve for x, remember I've got to use my order of operations backwards. So I start on the outside, I work my way in. To get this out of a square, I'm going to take the square root of both sides. So I square root here and I square root here. The square root of x plus 4 squared is x plus 4. The square root of 25 is plus and negative, positive and negative 5. Now I can set up two equations similar to what I've done in another section. So I'm going to have x plus 5 equals, I'm sorry, I misspoke. X plus 4 equals negative 5, and x plus 4 equals positive 5. And then I can just use some of my solving skills to get x is equal to negative 9, subtract 4 from both sides, x is equal to 1. This is the process of solving once I have a perfect square. The process of completing the square is making sure that I have that perfect square trinomial. So this is an ideal example. All right, we want to be able to solve quadratic equations like this even when it's not a perfect setup. All right, so this process of completing the square means adding a number so that you have an expression that is a perfect square. All right, so hopefully you've already done some review on factoring perfect squares. We're just going to look at these real quick here and kind of talk about what it means to have a perfect square. So when I have this equation, x squared minus 10x plus 25, I know that this is a perfect square because when I take half of negative 10, I get negative 5. And then when I take negative 5 and I square it, I get 25. Didn't leave myself a whole lot of room here. It's the same thing here. So for x squared plus 20x plus 10, I'm going to rewrite it so I've got a little bit more room. I'm sorry, plus 100. Right. I know this is a perfect square because when I take half of 20, which gives me 10, I miswrote, half of 20 gives me 10. And then when I take 10 and I square it, I get 100. And you can see the same thing here. So x squared minus 8x plus 10, I take half, I get negative 4. And then when I square negative 4, I get 16. Now, how can I write that as a perfect square? So the reason this is a perfect square trinomial is because it factors as something squared. So what is that something squared? Well, you could go through the process and you could, you could take x squared minus 10x plus 25 and you could factor it every time, right? We're very well versed in how to factor that. There is a shortcut though. And the shortcut is that this half of this number, all right, or whatever I'm squaring here, is this value. Okay, so here's my shortcut. I can factor this. I can rewrite this in factored form by doing x, all right, and then whatever half of this is, all right, is what goes here. So plus 10. Now we know that x plus 10 squared is x plus 10 times x plus 10, right? Just a note. All right, and then when I multiply that all out, I'd get back to the original equation that I have written in black, original expression that I have written in black. So take a minute, pause this, and see if you can rewrite these last two as in factored form. Okay, hopefully you had a chance to factor those, all right? So this one, x squared minus 8x plus 16 factors to x minus 4 quantity squared. And then this last one factors to x plus 3 quantity squared. And there's an opportunity for you to write your own. So maybe you can come up with your own. Okay? I won't wait around for that, but hopefully you can take a moment and just try to write one, all right, in standard form and then write it in factored form, something other than what's here. Okay, so now let's get into the solving. All right, solve the quadratic equation by completing the square. So I've got a lot of steps here. I'm going to break them down for you as I do the first one. For problem A, I've got x squared minus 10x minus 24 is equal to 0. The first step in my list here is to solve for 0. So what that means is that on one side of the equation, I want 0, and on the other side, I want everything else. I've already got that here. Great. The next step is to write the squared term and the linear term in parentheses. So I'm going to basically group these. Now it says only the squared term and the linear term. And I'm going to purposely leave some spaces here. All right. I'm leaving a couple of spaces here. I'm going to fill those in. Step 3, complete the square. So again, the process of completing the square is to find what number I add so that this is a perfect square. X squared minus 10x, okay, what does this take? So I go through this process and I take half of b, which is 5, negative 5, I'm sorry, and then I square that number. Negative 5 squared is negative 5 times negative 5, which is positive 25. So if I kind of go over and write this out with our formula, if I'm looking at x squared plus bx, then to find my c value, I'm taking half of b, and whatever number that is, I'm squaring it, and then that's what goes right here in this spot. So that's completing the square. I added the 25 in here. The next step 4 is to balance the equation. Well, I had a balanced equation, but now I just added 25 to the left side. Well, then it's no longer equal. I can't just add things to one side, right? I can't just add weight to one side of the scale. So what I have to do here is I have to subtract it back off. So I added 25 to the left-hand side. Now I'm going to subtract it back off outside the parentheses. So minus 24 minus 25 gives me minus 49. Step 5, I want to write it in this form. So I'm going to do two things here. I'm going to factor the left-hand side, and I'm going to move the 49 over. Let's move the 49 over first. We'll just get that out of the way. And now I want to rewrite this as a perfect square. So we practiced this above. Okay. When I'm rewriting this, this is always going to be plus b over 2. And this takes the sign of b. Okay, so it might be plus or it might be minus. Now this value that's half of b, okay, is always this right here. So I get x minus 5. Boom, factored. Okay. To continue to solve, I'm going to take the square root of both sides. So I take the square root of the left and the square root of the right. And when I take the square root of x minus 5 squared, squaring and square rooting cancel each other out. So I'm left with x minus 5. When I take square root of both sides, I get plus and minus. And then the square root of 49 is 7. I'm going to move this up here, make use of my space. X minus 5 then is equal to negative 7, and x minus 5 is equal to positive 7. I'm going to solve these two little mini equations. Add 5, and I get x equal to negative 2. Add 5, and I get x equal to 12. Now, seeing that for the first time is not supposed to be like, oh, I totally get it, right? It's not a lot of new stuff, but it's putting a lot of skills that we've practiced together into one big type of problem. All right. So we've got some more, and they're going to look very similar. Notice that for A, I had x squared minus 10x minus 24. This minus 10x means that when I factor this, I get a minus inside the parentheses. This one's a plus. So when I factor it, I'm going to have a plus inside my parentheses. Step 1, solve for 0. So this equals 1 is in the wrong spot. I'm going to move it over. So I have x squared. I'm going to group my square term and my linear term, and then the minus 1 I need to leave on the outside of the parentheses. Now I have equals 0. I kind of did 2 and 1. So I solved for 0 and I wrote my square term and my linear term in parentheses. Next step, complete the square. So I take positive 6 and I take half, which is 3. And then I take that value and I square it. So I have positive 3 here. When I square positive 3, I get positive 9. When I add 9 inside the parentheses, in order to keep my equation balanced, I have to subtract 9. So I'm adding 9 to the left side and then subtracting it back off. Now I've completed the square and balanced my equation. The next step is to write this as a perfect square and to move the 9 back over. Not the 9, but the 10. So I can factor this x squared plus 6x plus 9. Right? This number, half of whatever b is going to be what I put with the x in here. And I need to move the 10 over. And I have it written in this format right here, which is x plus or minus some number, quantity squared equals q. Now I do the solving part. If this video is going too fast, feel free to slow it down or just pause it a lot and take some breaks. All right, so I'm going to take the square root of the left side and the square root of the right side. Square root of x plus 3 squared gives me x plus 3. And then the square root of 10, I'm going to get plus or minus square root 10. Oh, what is the square root of 10? Well, if I take a look at my factor tree and I try to factor that, I get 2 and 5. Nothing I can simplify. Okay. So I come back up and I make 2 little equations. If you have more room underneath, you can just keep working underneath. I'm just running out of room, so I'm going to write it on the side. This leaves me with x plus 3 equals negative radical 10 and x plus 3 equals positive radical 10. Solve for x. All right, so in order to solve for x, I am going to subtract 3 from both sides. Now, we have been working with irrational numbers here, right? And these are not like terms, the negative 3 and the radical 10. So I can't necessarily combine those. I'm just going to write them as an expression. Negative 3 minus square root 10. And it's the same thing on this side. Now this is negative 3. This is a positive square root 10, so I'm going to write positive square root 10. You'll notice that these are the same. The only thing that changes is the number in front of the radical. All right. So there is a note here in red. It says, notice for all of example 1 that a is equal to 1. So We've got for A and B and C and D, all of these have a value in front of x squared of 1. And that makes these problems easier. So when we roll into example 2, we're going to see sometimes where the A is not 1, all right, and we'll kind of walk you through that. All right, but I just want to point that out. In order to complete the square, the number in front of x squared has to be 1, and if it's not, then I have to factor it out, and we'll get a little creative with that in a little bit. I've moved my steps down so that way we can see them again, and we're going to go ahead and continue with C and D. I'm going to work out C, and I'd like you, and then afterwards I'm going to give you ask you to pause and work out D. If you feel like, boom, I got this, then go ahead and work out C and D. Okay? All right, here we go. So first thing I got to do is solve for 0. So I want a 0 on the right-hand side, so I'll add 82 to both sides. When I rewrite that, I'm going to have x squared minus 2x. I'm going to leave that 82 outside of my parentheses. All right. And then I complete the square. So I take half of negative 2, which is negative 1, and then I square negative 1. It's important to keep your sign. Negative 1 squared is negative 1 times negative 1, so that I'm going to add 1 inside my parentheses. If I add 1 inside my parentheses, on the left-hand side of the equation, then I have to subtract it off so that my equation stays equal. This is part 4, which says balance the equation. All right. So I'm going to subtract 81 from both sides. And then I'm going to rewrite this as a product of squares. So how do I factor x squared minus 2x plus 1 if I know it's a perfect square trinomial? Right? So this is going to be x. It's always this value here. It's always half of b, so x minus 1. Make sure you got the sign right. It has to be minus or it'll be wrong. Then to solve, I take the square root of the left side and the square root of the right side. The square root of x minus 1 squared is x minus 1. And the square root of negative 81, I get plus or minus, oh, a square root of a negative. So we've just recently been practicing with this. The square root of negative 81, remember, is equal to the square root of negative 1 times 81. The square root of negative 1 is I, and the square root of 81 is 9. So this is going to give me plus or minus 9i. Okay, well, that's a little different. So now I've got x minus 9 is equal to negative 9i, and x minus 1 is equal to positive 9i. To solve, I add 1 to both sides. This is a complex answer. For complex answers, remember that the real part has to go first, and then the imaginary part. So I get x is equal to 1 minus 9i and 1 plus 9i. Such a good variety of questions, of answers here. Okay. Please pause this and do problem D. Go ahead and push pause. Give it a try. D is very similar to A. Now that you've had 3 examples, you should be feeling a little bit more comfortable with it. follow through with these steps and then use any of these as an example. It's most similar to A, if you want to reflect back on that one. When you come back, the solution will be up. All right, here is the solution for D. So you may want to pause this so that you can compare your answer and then compare step by step. If you didn't get x equals 3 and 9, you can compare step by step and see maybe where you made an error. Looking at problems and being able to find our error is a very important skill. Okay, it's called error analysis. So if you need a little more time on this problem, please take it. Otherwise, we're going to move on to example 2. So this is a different application of the same skill. All right, so I'm still completing the square. I'm still factoring perfect square trinomials. But now I'm going to talk about, instead of equations like example 1, I'm looking at functions. So remember vertex form of a quadratic function? If you forgot it, here it is. All right, so we're going to talk about, there's a lot that I could talk about for this vertex form, but there's 2 specific pieces of information that we need to be very aware of. If A is positive, all right, then this opens up. If A is negative, this opens down, right? Open up parabola, open down parabola. Other piece of information that we're going to need to rely on is HK is the vertex. So I take the opposite of what's next to what's next to X, and then K. Right? H for horizontal shift, K is the vertical shift. And there's a warning note in red. Remember, when completing the square, you must have A equals 1. If you have a different coefficient, then you must factor it out first. So if you look ahead at example 2, A, B, and C, A, I have an A value of 1. B, I have an A value of -1. C, I have an A value of 2. Okay, so this is going to be similar, except I don't have to solve for 0 because I don't have a 0. I'm just going to leave y over here. I'm going to group my square term and my linear term and leave my 71 out. I complete the square. So positive 16 divided by 2 gives me 8. And then I square 8 to get 64. If I add 64 to one side of the equation, then I need to also subtract it. When I simplify the right-hand side outside the parentheses, I get 7. And then on the inside, when I write this as a perfect square, I'm going to get x plus 8. I am misspeaking quite a bit today. Now, I don't need to solve, so this is kind of answers the question writing in vertex form. So this is vertex form. So that's part of my answer. So we just went from standard form to vertex form. The next part of the question for the problem says, identify the maximum or minimum value of the graph. All right, so we need a couple of pieces of information here. We need to look at the vertex. So in this case, the vertex, I'm going to take the number opposite x plus 8. Instead, is going to be a -8, and then 7. This is the vertex. Is that vertex a maximum or a minimum? Since A is positive, I know that this opens up. My vertex then is at the bottom of my parabola, therefore I have a minimum. Any maximum or minimum value when we're talking about, we're always talking about the y value of the vertex. So y value of the vertex is 7, therefore I have a minimum value of 7. And that answers the second part of the question. I'm going to do it again for B and C. Hopefully that felt quite a bit easier than when we started this lesson. But I am going to add a step. It's actually going to be adding 2 steps. Because now I don't have a equal to 1. Now for this problem, I have a equal to negative 1. So I have to do something else first. I'm going to group the square term and the linear term again. But now I have to factor out whatever is keeping my x squared from having a coefficient of 1. Okay? So I'm going to factor out a negative 1. And when I factor it out, remember I'm taking the GCF, so I'm just taking it out of both terms, right? I take out a negative, and then I'm left with a positive x squared and a positive 14x. All right. So I factored it out. I took it out in front. Now I complete the square. So I take half of 14, which is 7, and then I square 7, so I add 49. Now pause. I added 49 inside the parentheses. But the parentheses are all times negative 1. Oh, darn. So I added 49 inside the parentheses, but that's really 49 times negative 1. So I really have a minus 45. I'm sorry, minus 49. So to keep my equation balanced, I have to add 49. So I drew this little green like dashed line to make sure that you take that into account. And the rest of it's the same. So I combine like terms, minus 59 plus 49 gives me a minus 10. And then I rewrite my quadratic as a product of binomial. So I have x plus 7 that is this function in vertex form. Awesome. So I pluck out my vertex. What is my vertex? I'm going to take the opposite of 7, and then I have a negative 10 for my y value. All right, we have to ask ourselves, does this graph have a maximum or a minimum? A is negative. That means that this graph opens down. Since it opens down, that means my vertex is on top. Hence, I have a maximum. Now, a maximum value of whatever y is. So here I have a maximum value of negative 10. That answers the second part of the question. All right, we've got one more to do. The difference between, for problem C, is that now I have an A value of 2. So I'm just going to recognize that and move forward with it. Y is equal to, I'm going to group my squared term and my linear term, keep my 23 out of the way, and I'm going to factor out that 2. So I'm going to bring it out in front. When I bring it out, remember I have to bring it out of all of these. So don't mess with the x's, just take the 2. It's going to leave me with a minus 6x in here. I didn't take a 2 out of the 23 because I'm only taking it out of what's in the parentheses. I complete the square, which means I add 9 inside the parentheses. But wait, you took something out, so take that into account. I didn't actually add 9 because I really added 9 times 2. So when I added the 9 inside, I really added 18. So to make this equal, I have to subtract 18. Let's see, I've got a 23 minus 18, that gives me 5 over here. And when I factor this, I get x minus 3. So y is equal to 2 times parentheses x minus 3 quantity squared plus 5. That is my equation in vertex form. To answer my second part of the equation, I pluck out my vertex. I take the opposite of the value next to x, so positive 3, and then the positive 5. Since a is positive, this opens up, which means I have a minimum value. And my minimum value is always going to be the y coordinate, so minimum value of 5. Right, wonderful. I hope that went okay for you. Feel free to watch any parts of it again that may have given you a little trouble. And that is completing the square for some of the more reasonable problems, maybe some of the simpler problems. So that's about the extent of that we'll get into in this lesson. Thank you.